Hello guys, here's the first lesson of the week. This should be a fairly straightforward algebra review, pretty basic stuff. The topic is going to be called simple inequalities. So that's the review stuff that's, you shouldn't have a problem with. And interval notation. Interval notation may be new to you. Every so often I'll get students who've seen it before, but most students come to TOLS from your various schools not knowing this part. So I'm going to run through interval notation. I'm going to mention a couple other things and then get into the examples. So these are inequalities: less than or equal to, greater than or equal to, less than, greater than, and then you may have seen those before. They're called conjunctions. So I'm going to write these out in what we call interval notation. So x less than or equal to 5. That basically means every number less than 5 all the way up to and including 5. So not just 4, 3, 2, 1, but 0, -1, -2, all the negative numbers. So it goes to negative infinity, and then every decimal and fraction in between. So 4.9, 4.99, etc. So to rewrite this in interval notation, it's going to look like this. Okay? So when we say it goes smaller than 5 forever, that's negative infinity. So that's what this negative infinity is for. That's like the left-hand side of this, even though there's no left because it goes forever. But this inequality ends at 5. That's what this 5 here is for. And then the bracket means we are equal to 5 or including 5. If we had the next one, x greater than or equal to 4, it's going to look like this. From 4 to positive infinity. So greater than or equal to 4 includes 4. That's this square bracket. 4, that's the first or the starting number. And then how far to the right do you go if you're counting up or greater than 4? Well, forever. So there's infinity. And infinity always has a parenthesis on it. Now we have x less than -3. So this is going to look a lot like less than or equal to 5. Less than -3 would be like -4, -5, -6, all the way to negative infinity. So this interval notation is going to start negative infinity, and then it ends at -3, just like this one ended at 5. But the difference is there is no equal sign here. So this is not less than or equal to, it's just less than. So when that happens, you put a parenthesis on the 3 instead of a bracket. Similarly, for the next one, x is greater than 10, is going to be parenthesis from 10 to infinity, parenthesis. So a square bracket is like equivalent to having an equal sign. Square bracket, equal sign here, square bracket there. A parenthesis is equivalent to not having an equal sign. An infinity or negative infinity always has a parenthesis because you can't actually equal infinity. It's impossible. Okay, so the next inequality, x less than or 1 less than or equal to x less than or equal to 7, that basically says every number between 1 and 7, including the 1, including the 7. So that's going to look like this. Bracket 1, comma 7. So from 1 on the left to 7 on the right. 1 on the left, 7 on the right. Brackets because of the equal signs. The last example here, -2 is less than x is less than 8. This is basically saying x is every number between -2 and 8, but we're not including -2 and 8. So that would be like parenthesis -2 to 8 parenthesis. So if I went too fast through that, if you couldn't grasp it all, each example I do, I'm going to have an answer that looks like one of these, and then I'm going to rewrite it like that. So there's going to be a lot of practice on this notation as I go. But before I get too far into it, one thing about inequalities, whenever you multiply or divide by a negative, you must do something special. So if you had like 5x is less than 20, and you want to solve this, you just divide both sides by 5, you get x is less than 4. But if you had -5x is less than 20, you want to solve this, you'll have to divide by -5. You get x over here, you get -4 over there, not 40, 4. And then there's something special you have to do with this symbol. Do you remember it? You must flip the symbol. So this becomes x is greater than -4. So that was one of your algebra lessons that you previously learned, maybe forgot about. If and when that comes up, I'll make a big deal out of it. All right, as normal, I'm going to do the evens and check myself as I go, and then give you the odd problems for an assignment. Looks like there's only 12, so that means only 6 homework problems tonight. Okay, so number 2, I'm going to start by rewriting the problem down here so I have plenty of room to work it out. This can be simplified, so you get negative 10 is less than 10x. To isolate x, you have to divide both sides by 10. I'm dividing by a positive, so I don't have to flip the symbol. I get negative 1 less than x, and that is my solution. Or you could write your answer like this: x is greater than negative 1. You can flip inequalities around if you so desire. Just make sure that if you think of the inequality as a mouth, that it keeps eating the right thing. So here the mouth is eating the variable x. When you flip it around, it's still eating the x. So there's our answer, and if I go down and check it, there it is. Now we also need to graph it. So the way to graph this, negative 1 is right here, and we circle it. An open circle corresponds to the fact that there's no equal sign. If there was an equal sign, it would be a dot instead of a circle. And then here we say, okay, what numbers are greater than negative 1? Are they the numbers to the left, or are they numbers to the right? Well, greater than negative 1, bigger than, whatever, that goes to the right. So this would go this way. You can draw an arrow, or if you want, you can color it in like this, or color it in like that, or whatever, and that's what your graph should look like. So number 2, as far, oh man, getting lost. Uh-oh. What the heck? Did I do something wrong already? Number 2, oh, I'm checking number 1, aren't I? What a maroon. What an ignoramus. I only have the answers to the odd ones here. Okay, so I did something really screwy with this assignment. I don't even know how I did that. Well, your answers will be down here. You can check yourself. It'll all be good. I'm just going to say that I'm right. Now, I still do need to write this in interval notation. It's usually easier to take the picture and translate that to interval notation. So I'm going to make this picture a little neater. Okay, so this arrow basically goes from 1 to infinity. Or I'm sorry, from negative 1 to infinity. So it's going to be negative 1 comma infinity. Infinity always gets a parenthesis, and the fact that this is an open circle or there is no equal sign means that that also gets an open parenthesis. So there's the answer in interval notation. By the way, when you do your odds and you go down to check yourself, I will have written in the answers in interval notation in my own handwriting when you go to check yourself. So that's something to remember. All right, number 4. This one looks like a mess. Let me rewrite it so I have room to work this out. Actually, I'm going to go ahead and distribute this, save some time. 24x minus 20. Okay, I've got like terms right here, so I can put those together. Negative 134 is less than or equal to 19x minus 20, right? Negative 5 plus 24 is negative 20x, or 19x. Add this 20 to move it over there. I get, what's that, negative 114 less than or equal to 19x. Ooh, I'm a little suspicious. I got to divide both sides by 19 now, and I am going to pull up a calculator. Okay, my screen is going to flip over real quick. Sorry if it makes you dizzy. I need to pull up my calculator, and then I'll flip it back over. Okay, so let me do this right. Negative 114 divided by 19 is negative 6. Negative 6 is less than or equal to x. That cancels out. So there's my answer. For graphing it, I need to put a dot on the 6. Because there's an equal sign here, it's a dot, not a circle. The other way to write this is x greater than or equal to negative 6. You can flip it around. And that's helpful when you draw your graph. That lets you know that the shading goes in this direction. So it's a lot like number 2. Oh, if you hear my dog barking in the background, please forgive me. So, colored in dot, arrow to the right, answers are circled. If I want to put this in interval notation, it's going to be bracket, 6 to infinity parenthesis. Yeah, something's got my puppy all worked up. Sorry if that's distracting. He should stop any second now. All right, so the math that I'm doing and the graphing should not be anything new. And for some of you, this part isn't even new. Let's look at number 6. So I've got negative 70v minus 58 is less than or equal, I'll go ahead and distribute here, 90 minus 70v. Okay, I have to get my variables together, so I'm going to add 70v to both sides. That crosses out, and I get negative 58 is less than or equal to 90. Now wait a second. The whole point here is to isolate the variable. Like in this problem, we isolated x. In this problem, we isolated x. I mean, that's the point. And there is no variable here. It's completely disappeared. When that happens, you might, in this case, have a special situation. That could mean that either all real numbers are the solution or there is no solution. So this is a special case, let's call it. And so what you need to do is look at the result. Is negative 58 less than or equal to negative 90? Well, negative 58 is less than negative 90, so this is what we call a true statement, and that means that all real numbers are the answers. All real numbers. What does the graph of all real numbers look like? You basically shade the whole graph. You don't need to put a dot or a circle anywhere, just shade the whole thing. What does this look like in interval notation? Well, in interval notation, you're okay using the words all real numbers. If you want, you can use this symbol, this R with 2 sticks, in math lingo also means all real numbers, or you can do negative infinity to positive infinity. That's another way of writing all real numbers in interval notation. So this was a special case because of the way the variable completely canceled out of the problem, left us with a true statement. Let's look at number 8. I'm going to go ahead and distribute this and bring it down. Negative 7v plus 56 is less than negative 45 minus 7v. We have like terms on both sides of the inequality, so I need to combine them. I'm going to add 7v. I get 56 is less than negative 45. Once again, the variable has completely canceled out of the problem. This is another special case. But this time we look at the result. Is 56 less than negative 45? No, it's greater than. So this is a false statement. False statement means there is no solution. There is no number on this number line that you can plug into the problem and have it actually work out. It's just rigged to fail. So no solution is your answer. Good enough. There's a symbol for no solution, which is this. There is really no interval notation for no solution. You just go with the symbol or the words no solution. So no graph to draw. Just write no solution or that circle with a line through it. So what do we have? We've got a couple that worked out like they normally should. We've got, one without an equal sign. So there's that circle there, or the open parenthesis as we call it. There's one with an equal sign. That's the colored in dot, or the closed bracket as it's sometimes called. An all real numbers special case, a no solution special case. Let's look at number 10. Solve each, same directions. All right, so I'm going to go ahead and distribute here. I get 21b minus 21. Distribute here, that's going to be plus 5b minus 35, less than negative 56. All right, 21b plus 5b. I can combine those, get 26b. Negative 21 minus 35, that's going to be minus 56. To isolate the variable, now I know my b and my 6 look a lot like each other, and I've never been able to teach myself to write more clearly, so unfortunately for you, you're going to have to deal with that as you go through the school year. All right, anyway, let's solve this. Add 56 to both sides. 26b is less than, what's negative 56 plus 56? Well, that's 0. Divide by 26. You get the b isolated, less than. 0 divided by 26 is still 0. There's our answer. To graph that, again, there's no equal sign, so I have to circle 0. Less than 0 would mean you shade this direction. So there's what our graph or our picture would have to look like. The interval notation, okay, the left arrow points at negative infinity, so it's going to be parenthesis negative infinity, comma. The right end of the graph stops at 0, so it's going to be a 0 there and another parenthesis. By the way, if you put, oh, let me circle that. If you put 0 to negative infinity, that might be a way that you think of it. Oh, it starts at 0 and it goes to negative infinity. As far as interval notation is concerned, that's technically wrong. That's bad. Anytime you use, the parentheses or the brackets, this interval notation, this needs to be the smaller number and this needs to be the larger number. And negative infinity is clearly smaller than 0. So always do it that way. The other thing, well, no, let's move on. I'll scroll back up and talk about the other thing in a minute. But anyway, this is done. So we solved it. We got our regular greater than, less than, inequality style solution. We've got our graph, and we wrote it in the interval notation. Number 12 is our last one. So let me bring it down here so that I have room to work. I'll go ahead and distribute that. 8n minus 2, 8, yeah, 2 times 4 is 8. I'll distribute that. Negative 2n minus 8. These are like terms, so I combine those. 6n minus 10 is greater than, okay, 8n minus 2n is 6n. Minus 2 minus 8, those go together, that's minus 10. Okay, this is interesting. This side completely matches that side. What's that going to mean? Well, let's work it out as though we didn't even notice that. Go through the steps. Negative 10 greater than negative 10. Again, the variable is completely gone. So this is another special case. Special case can be either true or false, which means it could be all real numbers or no solution. So you just got to ask yourself, is negative 10 greater than negative 10? It is not. Negative 10 equals negative 10. It is not greater than. This is a false statement. Therefore, no solution. Remember, when it's no solution, you do not have to draw anything on the graph. And you could write the words no solution, but there is no interval notation with the parentheses and the comma or anything like that. So that is 12 examples you need to try. Or I'm sorry, that's 6 examples. You need to try the 6 problems. The answers will be down here for you, and I will handwrite in the various interval notations so you can check yourself on that before I save this. One thing I wanted to mention, when you end up with a scenario, let me get a different color highlighter, scenario like this that translates to that could easily be mistaken for an ordered pair, a point negative 2 comma 8, which you graph left 2 and up 8 and you put a dot. So this is one area in math where the same notation is used in 2 completely different contexts, and that could get confusing. So as you're doing this interval notation, remember that context matters, and what you're looking at all through here are not XY coordinates that you graph. So don't think of it that way. Okay, do the odd problems, check yourself, submit the assignment. If you have problems, email me or put comments, give me a private comment or a class comment. And good luck, and hope you have a great day.